Hello everyone, my name is Patavi. This is my team, Vishwant and Divya. So we are students of Anna Group of Institutions. We have done a project on blockchain under the guidance of Ms. P. Vinayashri, Assistant Professor at Anna Group of Institutions. Now, this video is about blockchain and the project that we have done. So we'll give you a brief idea of what this project that we've done is and how would it help clubs and communities. Now, I request Rishwant to go ahead with this part of presentation.
Blockchain. In recent years, there's a buzz on blockchain. Many have described that this is an important disruptive technology of the decade, especially the financial markets could have been the most affected ones. Technology has been adapted in many verticals like healthcare, medicine, insurance, smart properties, automobiles, and even our governments. However, so far the most successful implementation of blockchain is Bitcoin, a peer-to-peer electronic cash system which incidentally is along with the first implementation of blockchain technology. Thus, to understand blockchain, the best way to understand is Bitcoin system is designed as implemented. Uh, when coming to the brief history, the Bitcoin was introduced in the world by Satoshi Nakamoto through a research-style white paper entitled Bitcoin. The Bitcoin is not solved the double spending problem, but also offered many more advantages. One such advantage worth mentioning here is a anonymity in the transactions. Satoshi, who created the system and did transact few coins on the system, is totally anonymous to the world. Just imagine the world of social media when there's privacy to each individual is a stake. The world is not able to trace out so far who is Satoshi. In fact, we do know where Satoshi is an individual or a group of people. Googling is about also revealed the fact that the Bitcoin Satoshi Nakamoto holds is 19.4 billion. Next, publicly and private publicly cryptography. Publicly cryptography or a short PKI, is also known as asymptomatic cryptography. It uses two pairs of keys, public and private. The key is some long binary number. The public key is a distributed worldwide and is truly public, as its name suggests. The private key is only restricted to held private, and one should never lose it. In case of Bitcoin, if you ever lose a private key to the Bitcoin wallet, the entire contents of the wallet would be instantly vulnerable to theft, and before you know it, all your money would be gone with no mechanism system to trace out who stole it. That is anonymity to in a system that is mentioned earlier. The PKI accomplishes two functions: authentication and the message privacy through encryption or decryption mechanism. Next, authentication. When two parties exchange messages, it is important to establish a trust between the sender and receiver. Especially the receiver must try the source of message going to a earlier scenario. Hashing. One of the most important functions in PKI is hashing function. A hash function maps the data of an arbitrary size of data of fixed size. Bitcoin uses SHA-256 hash function that produces a hash output of 2 to 6 bits, and the further mining will be continued by Divya.
Thank you for that, Rishwant. So, as Vishwant has explained about hashing and different techniques, I would like to talk about mining. So, mining process in Bitcoin is very essential because that is how you validate and verify the transactions that get recorded on the blockchain network. So, as the entire network is widely distributed, every miner in the network is received. They are expected to receive multiple messages from multiple vendors. Generally, vendors are people that you can regard to as customers or people who sell and buy items. So, from all of these customers or these vendors, the miners will receive messages stating that this is my transaction and would you please validate my transaction. So at any given period of time, they receive many number of such messages. So what the miner does is he combines all of these messages and he puts it in a single block. Now in this single block, there are different messages. Let's say there are actors such as Alice and Bob. So there is a message from Alice, or it's a transaction that Alice has initiated. There is a message from Bob, that is a transaction that Bob has initiated at some point, at some place. It doesn't have to be at a certain place. It can be from South Africa or it can be from India. So picturize an image. So there is a box, and in that box there is a transaction from Alice, transaction from Bob, transaction from X, transaction from Y. Now this is a box that miner collects. Now what he does is now this particular box, whatever he has, he puts it in a hash function and generates a hash. Now this hash is what we generally look at when you are appending a block in the blockchain. There is a hash associated with every block. So after a block of message is formed, the miner creates a hash on the block using the hash function described earlier. Now, as you know, if any third party modifies the contents of this particular block, which means they are modifying the hash that the block already has. Now, every hash in a blockchain network is associated with the previous block's hash. So if there is a block n, that block's hash is associated with the n-1 block's hash. So if someone changes the nth block content, they can change the number of transactions being made, or they can choose a particular transaction, and if it's $1,000 that were transferred, if they make it $1 lakh, then obviously the content of that particular block will change, and also the hash associated with that block will also change. Now, since this hash is changed, the previous block's hash will also be affected, because there is a relation between both these hashes, and once this is changed, obviously this will also have an effect on it. So that is how you know something is happening in the network. Someone is trying to access the contents being not authorized to do so, and that is how you ensure that there is maximum security in a blockchain network. So it's generally when this incidentally each message is timestamped, each of the transaction in these blocks is timestamped. There is a certain time associated with it, so that nobody can modify the chronology of all these transactions. So the messages in the blocks are totally secured from tampering in this way. So this fact is what makes blockchain more secure in this particular period of time, and that is why people majorly trust blockchain. And the next concept that I want to talk about is chaining of blocks. Now that we have understood how verification and validation of different transactions takes place, let us now look at how blocks are chained. I've given a point on this earlier also. I've told you that there is a relation between each block. If there is an nth block, then there is a relation between n and n-1 and also n and n+1 block. The relation exists in terms of a hash. The blocks created by various miners are chained together to form what is known as a truly distributed public ledger. Now, in this particular ledger, all the blocks are chained in a sequential order. You can imagine different boxes which are tied together using a chain. So each block in this chain contains multiple messages, transactions that contains transactions, multiple blocks that contains transactions. A block in the chain may come from any miner. It doesn't have to be one particular miner that is generating all of these blocks. Whoever was able to find the hash of that block will be able to append this particular block to the blockchain, and that is how the chain continues. While creating the chain of blocks, we observe one rule, that the hash of the previous block is added to the current block. Okay, so in addition to this particular hash that we already had to the previous block, a new hash is created. That is the relation that exists between these blocks. So thus a miner, while creating the block, picks up the hash of the last block of the chain, combines it with its own set of messages, and creates another hash for its newly created block. So this newly created block now becomes the new end of the chain, and thus this chain keeps on growing as more blocks keep adding to this particular network. So that is how the activity of chain of blocks takes place in a decentralized network environment like a blockchain. Now let us look at a very important concept in blockchain, which is called the proof of work. Okay, all of the transactions are timestamped. This was discussed earlier also. We need to implement a distributed timestamp server on a peer-to-peer network. Okay, this particular activity requires some additional implementations, and that is regarded as proof of work. What it generally describes is, I'll give you a detail also. There is this important detail that you should not miss. For each block, we also had an extra element called as a nonce. A nonce will actually play a major role when deciding the hash of that particular block. So with the help of a nonce value only, you generally decide a hash of that particular element, whether it's a block or whether it's a transaction. So what is nonce? A nonce is a number such that the block's hash meets a certain criteria. This criteria could be that the generated hash must have its leading 4 digits. Now, hash is very big. Okay, it's 256, or it's very big, 256 GB. Sorry, bits. So, since it's so long, you will generally find many number of digits, and all of these digits are chained together, which makes a really big hash. Now, the first 4 digits of this big hash must be zeros. So that is the basic criteria that we follow when you are naming a block with a certain hash. Okay, so for example, the generated hash would be something like 0 and so on. So generally, the miner starts with a nonce value of 0 and keeps on incrementing it until the generated hash meets a specific criteria. Now, one should know that the hash generated at random is beyond your control. It's not that you accurately predict the hash. It's not in your control because the current power that we have, the current processing speed that we have, it's nearly impossible to accurately find the hash value with the current technology that we're currently having. Probably it'll be possible with the help of quantum computing, but that is all what we have for future. So generally, the expected time for generating a block in Bitcoin is around 10 minutes. So with the really advanced technology, you take 10 minutes of time to generate the hash that we were talking about earlier. Once the miner is successful with finding the hash, which means that he mined a block, he releases that in the system, making it now the last block in the chain. And the last block in the blockchain will be the one that he has released. One should know that there are multiple miners competing to generate the legitimate block, which is the last block, or which is the accepted block, a block that has verified and validated transactions. The Bitcoin system, first it awards the first successful miner by giving him certain Bitcoins. So generally these Bitcoins vary time to time. Previously it was 50 Bitcoins that people used to get when they mined the block successfully, and after 4 years it got reduced to 25. After 4 years it got reduced to 12.5. So you notice it getting halved every 4 years or so. That is how the Bitcoin system credits the person who actually worked hard to verify and validate all the transactions. In general, the miner with more computing power may be an early winner. Okay, so the people who has more advanced technology or tech stack that they're using, they'll have a greater probability to find the hash at a greater speed. So which means they have greater chance of winning. This can cause attacks on the entire system by those who possess a huge processing power. For example, there can be cases where two miners, they both mine the block at the same time and they also release the block at the same time. Then this will cause the whole blockchain network. Now I want you to visualize the whole blockchain network in the form of a sequential blockchain manner. Now if both of them release their block at the same time, then you will notice that there is a split there. One person will, if both of them are correct, if both of the work is correct, then whatever the sequential chain of blocks is there, it will divide into two parts because two people have submitted the block at the same time, which is generally what hypothetical, to be honest. There cannot be such, but there are many miners in the whole world who are competing for this. So if that happens, then there will be a split in the blockchain, and that is a problem that we have already witnessed previously in the Ethereum back in 2017, but we do not have to discuss it right now. So moving on, I want to discuss about network and mining. Uh, just to summarize what the steps that we have seen, anybody who wants to obtain services from the third party who has advertised on the network first creates a transaction. Okay, if you want to go buy something and the person accepts bitcoins, then you first initiate a transaction. That is the first step. Over a given period of time, there could be many senders or many buyers. So many transactions roll in every point of time, and all transactions are broadcasted on the network to all nodes. There is something called as transaction pool in the Bitcoin system. If we talk about Bitcoin, then in that transaction pool, all of these transactions come and get stored. Each node assembles the new transaction into a new block. Okay, so this miner node is what we're talking about. They take all of these transactions and they put it in a block. Now, the set of transactions in each block is independent of the set in blocks created by others and will naturally be different from others. So let's say I am a miner. I take transaction. Now there are 5 transactions: A, B, C, D, E. Now I take A, B, and E in my block. Now if you're a miner too, and you take C, D, and A, so both of us we're different. I took A, B, and E. You took C, D, and A. The number of transactions that we have is different, but we're working on validating these transactions. Now, how do a miner choose on which transaction to take? There is something called as incentives that senders or the people who initiate transactions do. They generally tell the miner that if you verify or validate my transaction, I am willing to pay you 1 Bitcoin or 0.5 Bitcoin or 2 Bitcoin sometimes. In that case, miners will choose transactions that will profit them more. They will not go to someone who just pays them 0.1 Bitcoin when there is someone who's ready to pay them 2 Bitcoins. So that is how they prioritize the transactions that they are taking in to validate. Okay, so now after miners take it, they now work on proof of work. They try to find the hash of the block, all the transactions that are there in the block, which basically is finding the hash of that particular block. The nodes then receive the new block and will accept it only after verifying that all transactions in the block are valid and not already spent or have some issues with the timestamp. If the blocks is accepted as valid, the node which is working on its new block, will have to resemble the transactions in its block, ensuring that the transactions are not duplicated. The node now works on finding the proof of work on its newly created block. While doing so, it will take the hash of the accepted or the previous block. Likewise, the blockchain keeps on growing. Okay, now one person adds a new block. Now, once this person adds a new block, the existing miner who is working on other set of transactions, he will take this hash and append it to the hash of whatever that the transactions that he's been calculating. And that is the process of mining, and that is how the network and the process of mining work. Now, the last thing that I want to talk about is incentives to miners. This is something that I've already talked about. So incentives in miners is something that that is very crucial when miner decides which transactions that he should consider, because most of the time they go for transactions that pay them more. As I mentioned earlier, some people who initiate transactions will be willing to pay $2 or 2 Bitcoins or 1 Bitcoin, and some people would not be able to afford 1 or 2 Bitcoins, so they just restrain themselves at 0.3 or 0.4 Bitcoins, which is quite less. But obviously, the miners will also get Bitcoins if they solve the particular math problem that they're having, which means if they release a new block, then obviously they'll be credited with Bitcoins from the Bitcoin system itself or from the blockchain system. But also additional source of revenue for miners is the incentives that will be given by the sender or by the people who initiate these transactions. So as I mentioned earlier, whatever the credited Bitcoins are there from the blockchain system, they keep getting halved every 4 years. So you can realize it's been around 3 quarters, I guess. I mean, 3 times it has been halved until now. So which basically means that we're at 50, 25, 12, 6. So 6 bitcoins or something that people will get, miners will get. Approximately 6 bitcoins is what miners will get. But after 100 years from now, you'll notice that this number keeps getting closer to zero because it keeps getting half. So the number of bitcoins that people will get from the blockchain system is very less. Now, how do the system keep going even after 100 years? Is even though there is no revenue from the blockchain system or there is to the miners, whatever the bitcoins that senders or buyers will give them will play a major role in deciding which transactions that miners should take. They will act as major source of incentives for miners, and that is how the blockchain system will keep continuing even after 100 or 150 plus years. So that completes my part. I request Divya to take over.
Yeah. Thank you, Patabi. So, until now, we have discussed what blockchain is, its intro, and how it works. Let's now discuss about the payment verification. While a block of chain is added to when a block is added to a blockchain, it gets miners gets paid for adding them and verifying them. So let's verify how these miners get paid. So consider a case whereby, as a vendor, you may like to verify a certain payment made in the past. As a blockchain you are holding on your machine contains only the block header, so the transaction that you are searching for is missing in the copy of your blockchain. You can now search backwards in your copy of a blockchain until you find a block in which the desired transaction is timestamped in. Now request the Merkle tree of the selected block and you will have the transaction you are looking for. So let's here uh, the blocks are verified before the transaction is made, and you know this is how the block acceptance of the miners is made, and how the miners are paid for adding blocks to the blockchain. Thus you can safely trust this transaction and proceed with your business. So now let's look at how resolving conflicts. If there are any issues while adding blocks to the blockchain, how these results are issued and how they are being solved. So as we have seen that the Bitcoin networks contain several miners. It is possible that the two different miners solve the proof of work at the same time and thus add their blocks to the last known block in the chain. So now we have two branches after block 3. Both the branches are valid. So the next mined block may be added in either of the branches. Like suppose we have a block when many blocks, and at the same time both blocks are added to a single block. I mean a single block is connected to multiple blocks at a time. So this creates a conflict. This conflict has to be resolved, and so the next mined block may be added in either of the branches. So it can, if suppose like two blocks are added at the same time to previous block, which block has to be considered is a major conflict here. So this is let's discuss how this is being solved. Suppose the miner adds the newly mined block to the previous block. The branch containing the previous block will no longer will be longer than the branch containing the I mean, we have two blocks which are being added to the previous block, right? Suppose block A and block B. So when we add block A to the previous block, the branch containing block B will be the longer than block A. So in Bitcoin architecture, the longest branch always wins, and the shorter one are pure. So block B has to be pure. Before purging this block, all transactions in this block will be returned to the transaction pool so that they are mined and added to some future blocks. This is how the conflicts are resolved, and only one single chain of blocks is maintained by the system. So that this is done because a single blockchain cannot have branches like multiple blocks or multiple copies of blocks. To solve this issue of copy, they they uh, they remove either of the block and maintain a single blockchain. So now let's look at privacy. How privacy is maintained in a blockchain. As the ledger which is recording all the Bitcoin transactions is made truly public, the privacy is at stake. Anybody in the world would be able to know whom paid whom. The traditional banking system is able to maintain this kind of privacy by keeping its records confidential. Privacy in Bitcoin system is achieved by a different strategy. Note that we said that the sender of a Bitcoin needs to know whom to pay. So he asks for the public key of the vendor to which he decides to make the payment. So in public key cryptography, we have seen that each of the user have a public key and a private key. So the privacy of the user is maintained using the private key of a block that is being created. So here the system maintains the public key records, which is used to verify whom the transaction is made and with who has initiated the transaction. And the private key is purely required for the privacy of the system and for the privacy of the users who is making transaction using the Bitcoin. So, the in the sense, as a vendor of some services, when somebody asks you where to send the payment, you would simply send him your public key. The association of the public key with you is not recorded anywhere in the ledger. That way, anybody outside of the transaction would only know how much money is transacted and to which public key the money is paid out. To achieve the higher degree of privacy, for every transaction, you may generate a new private or public key for each transaction so that multiple transactions made by you cannot be grouped together by a third party. For an outsider, this would simply mean that multiple transactions of smaller values were made and they will never be linked to a common source. Lastly, any online internet based system is vulnerable to abuses. I will now so this is how many in many online services there are many attacks that has been made like cyber crimes which in which many people have to lose their lose their money or lose their transactions. So in the blockchain there is no issues which can be made because only when the public key and private key of a person is accepted, the transaction of a person is made. If not, the transaction is never recorded and never initiated. So let's coming to a conclusion. Blockchain. You were introduced to several concepts of blockchain by Bitcoin in this content. So, the Bitcoin is the first successful implementation of blockchain. Today, the world has found applications of blockchain technology in several industries, where the trust without the involvement of centralized authority is described. So, this is how the blockchain works, and this is what a blockchain is. It's all about mining and cryptography, and also the safety and privacy of the users. So now let's continue with the project we have made, and that will be continued by Patabi.
Yeah, Prishwan, can we get the presentation? So our project basically is we tend to support students. So there are different clubs and communities that you find in schools and colleges. Now, when we talk about a school and a college, there may be many issues uh, that students might uh, disapprove on. There might be different opinions that may raise. So we wanted to provide an interface. We want to provide an application wherein students can get their ideas. Let's say there is a club that we're talking about, and this club has 20 students, and in that club, if 5 students have different ideas that they want to do next, let's say it's the next event that the club should organize, and 5 students have different ideas, how do we manage or how do we streamline everything in the right way and the best idea is taken out from this? This is what triggered us to do this application, and this application is where we have created an interface wherein students can write what their idea is, and through blockchain backed voting system, we have uh, we have uh, designed the application in such a way that students will vote for their proposal, and from there everything will go in place, and the number of votes, I mean the proposal that has got the number of votes will be taken into consideration, and the respective club will go ahead with that idea. So we actually want to mitigate all the conflicts that may arise in a club or a community and maximize its productivity. So that has been the major element which led us to take this project today. So I request Vishwant to go ahead with this presentation.
Yep. Well, talking about the presentation, let's start with abstract. In today's students, innovation is an integral part of not only students' overall growth but also the societies. Clubs and communities that are located in universities play a vital role in bringing up minds together and collecting solving problems. But oftentimes, multiple opinions and choices can lead to conflicts between the members of these clubs that negatively affects the productivity. For this, we intend to provide communities with an interface where proposals from the club members are posted, reviewed by the faculty in charge, and allow the club members to vote anonymously on the proposal. This helps in decreasing the possibility of complete accounts. This voting system will be powered by a blockchain system in the backend and a simple web interface in the front end as to accommodate non-technical users. In introduction, the difference in opinions exists in every part of our life. A voting system is believed to be one of the most transparent ways to settle down any differences in opinions of people. But even in today's voting system, there are many flaws and conflicts. To get out of those, we developed an application with blockchain as its backend and an interface at its front end, with the students can where students can anonymously and transparently vote to the best proposal made in that club. This provides a tamper-proof system for proper voting in the organization. It will also reduce chances of dispute or any malpractices, disbelief or about the voting system. There are only few existing systems. Those are through non-level voting system, uh, through a third-party election system, and there's a one where ideas are proposed, and the one who is a community board leader chooses the one. Then the other one is the only one who proposes the idea is selected, and others will be postponed for the review. There are many flaws in this existing approaches. The main flaws are voting system is done through a third-party member where the voting people may have many questions and doubting on the voting process. And the other one is if one of the ideas accepted, then there is dispute in the community as the productivity may decrease. If the decisions are decentralized in this kind of voting system, it may differences in opinions and there may be many clashes and conflicts between the people in the community. While coming to the motivation, right, if this is a part of a college club, college clubs, communities where they are facing many problems on deciding what activities should be taken forward. This is one of the most reliable and effective way to avoid any of the conflicts in the club. For this, we have come up with the idea of building a blockchain-based application that provides anonymity, tamper-proof, and easily adopted by any organization community. With such a in place, it decreases the truth about the decisions being made and gives us no scopes and conflicts. Then the further aims and objectives will be conveyed by Divya.
Yeah. Thank you, Rishwan. So, coming to the aim and objective of our project, through the proposed system, we aspire to complete the below objectives as you can see on the screen. So, the main objective is like improve the trust among the peers of the organization and help increase the productivity. So, when the decision is made through these voting systems, everyone gets an equal chance to vote for their opinion, and the one which gets highest votes will get implemented. So this increases the creativity and also creates a healthy environment among the peers of the organization and increases the productivity. Improve the trust in voting process carried out for the purpose of decision making. So when voting is conducted through this method, everyone as it is a transparent voting system, everyone in the system can have a trust on this system, it's a, true voting system without any uh, conflicts being made or without any cheating being made, because as the blockchain is a very secured system, it gives trust to the trust in the process and reduce conflicts or disputes that may occur due to differences in opinion. So, when there is a manual voting system, there may be many disputes among the peers, they may feel that their opinion is not being considered, or the some of the people are giving more importance. and this can be reduced by using this system, because everyone gets a chance to vote for their choice, and the, so this creates a healthy environment as well, and decrease organization cost for voting system. So as this process is completely online, this reduces the cost of paper and man for conducting the voting process. Easy and rapid result reporting and publishing. So after the voting process has been completed, the results can be generated within uh, less time than the manual thing. So it's a very rapid, easy and rapid one. Coming to the project methodology, so the project starts with the community members uh, uh, proposing their ideas in the interface, and then once the members of the community has proposed their ideas, the faculty head or the admin uh, verifies the proposals, and the ones which are related to the topic or one which are related to the conflicts that are being considered, and the faculty members or admin registers the users or community members as the voting members, and the uh, topics are being displayed to the members. And next, the faculty coordinator announces the date and time on which the voting has to be made, or vote has to be uh, made. So on the day of voting, the users has to cast their vote, and once all the members have casted their vote, the voting phase completes, and then the next the result is being calculated, and the result is being displayed to all the members of the community. So the winning proposal will be considered, and the community acts along with it. So at last, when the result has been declared, the community can choose their own. The community can choose the one which has been declared and go with that one. Next, when next system architecture will be continued by Patavi.
Yeah, thank you, Divya. So, whatever the methodology that we've discussed until now will give us a good clarity of how things work. Now, system architecture will also add few points to it. Now, this gives an idea of what the web interface will look like and what will it want. So, the web interface will want the public key and private key of the person who is voting. Now, generally, we do not have an authentication system in our application. We are using it via MetaMask. Everyone will be able to access the application and different elements of the application, but they won't be able to do anything if they do not have ethers or test ethers, which we'll be using in our application. So, when will they get test ethers is when they actually connect their account with the application through MetaMask. So MetaMask will also act as an authenticator here. Now, in our web interface, we will also have these options A, B, and C, and now these denote the proposals that we'll be getting in our web interface. So for easy denotion, we have mentioned them as A, B, C. Now, whatever the transaction or whatever the activity which were recorded on the web interface, they will be recorded on the blockchain system. Now they'll be recorded as transactions, which is an important point to be noted. And these transactions, we do not have a physical miner here. So we already have an automated mining script. This miner will take different transactions, validate them on the basis of the timestamp, the number of ethers that we are using uh, to roll out the transaction, and different elements like that. And all of these elements will be taken into consideration, and whatever the automated miner script that we have will validate or verify the transaction, and then it will go and get broadcasted to every node that we have on in our private network. Every node means, let's say there are 20 students in the club that we're discussing about, and there is one faculty coordinator. So there are a total of 21 nodes. So for every 21, this particular transaction will be recorded. So the so-and-so public key was voted, it was successful. So you have details of what is happening. So everything is transparent here. I just want to quickly highlight that point. And after that, once the transactions are which are placed in a block are verified, all of these transactions are put in a block. There'll be a hash associated with it. We'll be able to look at the transaction history. There is a separate web portal for it too. And finally, when the whole transaction process is done in the final step, so there'll be so we'll get the final result, which everyone will be able to look at. So everyone will now have the data of who exactly have voted, and since it's everything is getting calculated with by the code that was already written, and there is no third party being involved here. Generally, in a voting process, you'll find a third party who will uh, look at the code. Look at the number of votes that were rolled out. So they physically count each vote, but here it's a system that is counting each and every vote. So there is no scope of errors. There is no scope of cheating. So whatever the result that you'll be getting is 100% correct, and that is how the whole system architecture or this whole system is designed, and that is what we understand from the system architecture. Can you go to the next one? Rishwan, next one. So these are the diagrams that we have. So the first one is use case diagram. So all of these human diagrams, they give us a good clarity of what the application is about, what are different characteristics or constraints that we have considered while we were designing this application. So I just wanted to quickly highlight what these diagrams will talk about. Now let's get into what use case diagram is. That use case diagram is where you'll find different activities and different actors who participate in these activities. So we have creating ballot. Creating ballot is simply creating the voting process, and then making proposal. We have storing the proposals. We have renewal of proposal. We have registered voters, voting process, and declare winning proposal. All of these are activities. And for when I talk about different actors, we have chairperson, we have a student, and a database or a blockchain backend. So if you look at it closely, creating a ballot is what is where the chairperson and the blockchain backend are communicating. So since it's smart contract, obviously chairperson must initiate it, and the record of him initiating will be recorded in the blockchain. And then next, making proposal, it is obviously done by a student. Storing proposal is where the blockchain will come again. It's the backend that the light server that we already have, which takes care of it. And then the renewal of proposal will be taken care by chairperson. Registering voters, we cannot simply register everyone. We will only be able to register people who belong to that club. I cannot register someone from a different club just because he's my favorite student. So chairperson is simply the faculty coordinator. Only faculty coordinator will register students, and everyone will be able to look at who the faculty coordinator is registering, and there'll be no scope for cheating there too. And voting process is obviously where you will find a chairperson and student, both of them being engaged. And the declaring of winner is obviously you'll have to fetch the data from blockchain, and it will be displayed. And who fetches this data? So this is a command which will be executed by chairperson. So you see a connection between chairperson and a blockchain backend when we're talking about declaring winner. So this is what the use case diagram talks about. Next. So for class diagram, we do not have many classes in our smart contract code. So we have a chairperson and we have a student class, because both of them are pretty important in our application, and different weight is given to both of these actors. So for both of them, the attributes are same, but the number of functions that they have is different. So chairperson will create a ballot, register, declare winner, approve proposal, whereas a student will only put forth the proposal and vote. Next. So this is a sequence diagram that we have. First, the user, he uploads the proposal. So three actors are namely user, admin, and the web interface that we have. So in the first step, uploading of the proposal will take place, and after that, the admin will approve different proposal, and some of the proposals are right away rejected because admin is faculty coordinator. Faculty coordinators know what is good and what is not good for students. So let's say the students they suggested an introduction to blockchain session, but it was already conducted last week. So faculty coordinator might think it's unnecessary to conduct it, and he or she will reject it right away. So that is that happens in this phase. And after that, there is a login. Login is, as I mentioned, will be done by MetaMask. After that, the admin or the faculty coordinator will register the users. And after that, the voters will log in. So after registering of voters, it's not that they straight away come and they vote. They need to register. They need to register themselves. They need to log in themselves using the MetaMask interface so as to actually use their ethers to perform activities like voting. So next is adding a vote or so the voting activity basically, and then initiate result transaction. So result transaction is where admin will execute a command by clicking a button. So basically, you'll ask the blockchain system, you'll fetch the data of the winner, what the winning proposal is, what is it about, and who has proposed it. So all of this data is fetched from the right server, and this is displayed as a result to everyone who is in the node. Next. So this is our activity diagram. So start. This just basically describes different activities that we have. We have an upload proposal, and after that you'll have an approved proposal. So it has two different. It's a condition wherein one you get rejected or two you get approved, and after that admin login. So basically, Rishwan, can you just go to the last screenshot slide? Just a second. I just wanted to quickly look at something. Screenshots, final output. Okay. So go back to the same slide. Activity diagram. Yeah. So after that, just zoom in. So after that, if the proposal is accepted, it will be added to the interface. And after that, the login activity will take place. It's actually conditional, but since the activity diagram is getting very big, we have mentioned it as a state itself. So admin login will take place, and after that, voter registration is done. And I'm sorry, I got it. Okay, so approved proposal is where you get to reject or approve, and after that it gets added to the interface, the proposal, and after that the admin login will take place. Voter registration, it can be successful or unsuccessful, so that is why you have a yes and a no. And after that, registering voter is done, which is a state, so it has net shift. Next page. Next. Yeah. So after registering the voter, you have the voter login. After that, voter login is again a conditional, but since it's getting quite big, we have put into a state itself. And after that, the vote casting is done by the voter. Now, the transaction, which was the transaction, obviously the vote casting is recorded as a transaction. Now it is validated. So conditional again, validate the transaction, whether the timestamp is right, whether the number of peters that were used is right, the gas points or gas limit is right. So all of these are checked. And after that, vote is casted and declare results. Here, if it's chairperson or faculty coordinator who is asking for the results, then only it will accept. If it's not, then reject it. And after that, the results are declared, and that marks the end of the whole process. Next. Yeah, so tools and technologies. For technology, we have an Ethereum server, which is on the Ethereum virtual machine itself, where we're deploying our system. And Ethereum is the technology that we're using, blockchain technology. So that is why we have an Ethereum server. Solidity is the programming language in which we're writing the Solidity code. So that makes sense. And HTML, CSS, JS are the light front-end stack that we're using in order to build our web page. And Truffle IDE is integrated development environment, which allows us to do certain activities such as adding a voter, initiating a smart contract transaction. So all of these privileges are given by Truffle IDE. We also have written a test code for our application, and this was written in JavaScript. For tools, we have smart contract. Smart contract is like the soul of our project, wherein you tell the application what is right and what is wrong and what has to be done. And application binary interface is there, through which we get different artifacts, Web3 deploy, and all of them. And Ethereum virtual machine, Ethereum APIs and management APIs. In Ethereum API, so management API is where you get to have privileges such as adding a node, uh, starting the miner, and all of these activities come under the management API. Web3 API is used for uh, deploying our blockchain or on a front end. So basically, it's like an attachment between both our front end and our blockchain backend. And MetaMask is the application. It's a wallet management application through which uh, we keep a track of our transactions up until date, and we also keep a track of the number of ethers which were used in our activities. So that is the reason why MetaMask is used. Next. Yeah. So Divya, will you take this? Or?
Yeah, sure, Patavi.
Okay.
Continuing with the module description, so we have actually uh, three modules in our project. So the first module is the interface we are using. So in the interface, the users can register themselves, or the admin can register using the public key of the user, and the private key is generated for the user for the purpose of voting when the on the day of voting. So the user can upload their ideas or proposals and also validate them. So when the user uploads them, the admin can also validate from the interface, or from the interface the user uploads the proposals, and also whether their idea is getting accepted or rejected is also known using the interface. And they can also view the poll results here. So at the last, after the completion of the voting process, the results are also displayed on the web interface itself. And validating data. Validating data is checking for the timestamp of data entered and also the transaction ID. This is basically the time at which the data is being generated, and also the transaction ID and the timestamp of which the data is added to the blockchain system. And here, validation of user and data is done with the help of automated miners. In this project, we have used an automated miners of code which automatically validates the data that is being attached to the blockchain before being added to the blockchain. So here, the validation of data is done automatically. And next, after the data is being validated, and next the data is being converted into blocks so as to attach it to the existing blockchain. So here, after the data gets validated, the data is stored in the blocks according to the timestamp of each user. So based on the timestamp, the data is created and data is validated. The blocks are added according to the system. All the blocks in the system are connected with each other in the blockchain through the private and public key. So the the hash of each block is connected with the previous block's hash. So each of them are connected, and the uh, blocks are connected with the timestamp they are created and the time they are validated. So in this way, a blockchain is created for our system. Going to next, uh, this is the sample data which we are being used in our application. So this is for creating the voting system, and how the uh, proposal is being selected by the admin, and how it is being validated by the admin. And coming next, this is the interface code. Here we are using JavaScript for creating JavaScript and HTML for creating the interface, which makes the user very easy for using the interface. And here the user can upload their proposals and also check whether their proposals are getting validated or not. And then here the user can also check for the results of the voting. Next, this is the sample test code. Um, and this is sample outputs of what our project is. So here, these are the four sample proposals we have mentioned. So each of the proposal is being approved by the admin, and then the users can the admin can register the user with their address or with say public key into the system, so that the users has the right to vote in the system. So once the registration is done, the admin will declare a date for voting process to be conducted, and on the day of the voting process, the voters can vote from the place they are, as it is an online voting system. Arishman. So here, the user can pick their proposals, or the admin can select the proposals and add it to the interface. Next.
And just go to the last one. Which one? Go to the previous one. Previous one. Second image. Previous one. Yeah. So here you are also able to see the MetaMask application to the right. So that has the list of transactions that were recorded until this point. So these two transactions, they only belong to one particular account, whether it's the account of a student or whether it's the account of a chairperson. Now, all of these are the web interface and the different proposals that you have. So, Patavi, Devya, Rishwant, and all of that. So, both of them, the web interface and the MetaMask, both of them, they act hand in hand when deploying a transaction. Next. So here, one particular activity has been taking place. So as you can see, successful vote casting. This particular public account, they have casted a vote and they're getting a reply back through the JavaScript alert command or alert function. And that is how you actually get to know if it is a success or not. And if it's not successful, it will be unsuccessful. So that is how you also know that if the transaction is successful or not. And the reasons for unsuccessful transaction might be the timestamp or the number of ethers might be different, or there might be an error in the function code itself. So next. So here, so this is where registration is successful, as you can see in the alert box. So once chairperson registers someone, and if it's successful, then they'll get this message. Next. Okay, and this is when the whole voting process is completed, and the chairperson will click on the declare winner button that you're looking at here, green color one. So once they click on that, they'll get this alert pop-up which gives the details of the person who has proposed that particular proposed that particular proposal, and also what proposal that particular person has proposed. So, but here, Patavi, let's conduct a session on basics of blockchain is the winner. So we can replace this particular one with something else too. So it's just a change of code that we should do. So that is how you get to understand who the winner is, and everything, counting and everything will be done automatically. Chance of getting it wrong in the backend if the code and everything is right, which is right in our case. Next. Okay, we'll go ahead with conclusion.
Yeah. So from these things, we conclude that the proposed blockchain voting system has great potential to decrease organizational cost, improve voter turnout, improve trust among peers, improve trust in the voting system, reduce differences in opinions and potential conflicts. So apart from these benefits, it also eliminates the need to print ballot papers at polling station voters. Voters can vote from wherever they are using a simple internet connection. This helps in faster reporting and publishing of the results. So the voter need not to go to the ballot station